Hi, I'm Debbie. I'm an SRE at Google. When I first started, I primarily worked on infrastructure that enforced reliable mobile production changes. During this time, I learned how powerful experimentation could be for mobile reliability and beyond. And now my focus is improving experiments to enforce service reliability and how SREs can use experiments to make incident management for complex systems a little bit less overwhelming. So first of all, what are experiments and how are they commonly used in developing software? So traditionally, developers have used A/B experiments to measure usefulness, popularity, ad revenue, various metrics of a newly introduced feature. A basic A/B experiment has one control and one treatment arm. The control arm of the A/B experiment corresponds to the service with no changes made to it. And the treatment arm corresponds to the service with the change made to the service. So the phases of an experiment, I like to think of it as very broadly summarized as ideation, trial, and launch. So during ideation, a developer wants to introduce a feature. The developer may ask, will my feature lead to increased app usage in order to measure app feature popularity? And then after the ideation phase, the developer creates the experiment to enter the trial phase. To go into a little bit of detail, to create an experiment to enter the trial phase, the developer needs to guard the new feature code with a switch. And then as the experiment rolls out, it randomly switches on the feature for X% of the user population during the trial phase. So during the trial phase, the developer will roll out the feature gradually to see if the feature does increase app usage. And in this case, the developer will first trial this at 10% of the user population. The trial phase can include multiple parts. The developer may wish to trial the feature on a smaller population and then move to a larger population. For example, during a trial phase, a developer may choose to roll out first to the 10% as noted here, and then to 50%. So if at each subsequent trial stage, the feature works as intended and indeed is well received by the user population, the developer can then launch the feature to the entire population in what we call the launch phase, where the new feature becomes a permanent feature. So from the developer standpoint, the metric that determined if the feature should be launched was feature popularity or usability. From the SRE standpoint, however, the metric that determines if a change should be launched fully in production is often reliability. So in addition to measuring the popularity of the feature, an SRE can require that the new feature be launched if and only if the new feature retains the same level of reliability as the app achieved without the feature. So in this scenario, during the ideation phase, the SRE asks, is this feature reliable? And enters the trial phase similarly and rolls out the experiment to 10%. So during the trial phase, if the application does see increased app usage, but also sees increased crashes during this phase, we do not launch the experiment or the experimental feature to more of the population until the increased crashes have been fixed. So we don't enter the launch phase in this case. In this way, SREs can measure feature reliability in a similar way to how developers measure feature popularity. So now that we know what experiments are and how they're commonly used in the industry today, how can SREs use experiments? I alluded to this a little bit in the previous example to how an experiment can help SREs determine if a feature is reliable enough to be launched to production. But let's delve into how experiments reinforce and aid many SRE best practices. So incident management for complex systems can be quite overwhelming. And oftentimes during incident management, we need to pull in a lot of these SRE best practices. So as mentioned before, incident management. We often ask certain questions such as what part of the system broke? And once I find the potential root cause for the system failure, how can I mitigate the issue? So in order to answer these questions and thus make incident management more manageable, there are 3 SRE best practices that stand out in my mind. And those are gradual rollouts, change attribution, and the ability to mitigate a specific change attributed to the cause. The 3 SRE best practices I've mentioned here are really built into experiments natively. So how do experiments actually reinforce these 3 SRE best practices? So for example, gradual rollouts, at each stage of a rollout, we verify that the production change is as intended. So this allows us to limit a potential outage to a smaller blast radius. That is the purpose of gradual rollouts often in terms of SRE best practices. Because experiments are intended to be rolled out to a subsection of the population, we can use this built-in experimentability to execute gradual rollouts. In order for SREs to resolve outages, SREs need to know what the outage's cause is or roughly where the outage root cause is. Because experiments guard a feature change, if SREs can associate an outage with an experiment, we can then associate the outage with a production change. And this allows us to easily attribute the root cause of the outage and then take appropriate mitigation techniques. And sometimes during incident management of a complex system, we can't just roll back to the most recent state or the most stable state because it is a complex system. A lot of the questions that may come up are, what if we break a dependency of our very complex web if we roll back to a more stable state? And so sometimes we need more fine-tuned mitigation techniques. And this is really where controlled mitigation is very powerful in the SRE toolkit. Controlled mitigation via experiments is possible because experiments embody both gradual rollouts and change attribution. Because experiments guard new code paths and experiments give us the ability to track and mitigate an issue without rolling back the entire binary. An SRE is able to roll back tracked specific production changes. So in the next couple of slides, we'll see some hypothetical examples showcasing experiment-based incident management. So in this example, we use experiment-based incident management to reduce the outage impact. Let's say we've ramped an experiment associated with a new feature to 1% of the population. At 1% of the population, we see there's an increase in crashes and latency associated with the experiments. So with this change already, instead of affecting 10%, 100% of the population, since the feature was only rolled out to 1%, we've limited the potential blast radius of this outage. This may have been a medium or a major outage, but we ended with a minor incident. So at 1%, we see the regression and reliability metrics, and we can take mitigation actions. So at the very least, we could stop ramping further, or even better, we can roll back the experiment to mitigate the issue for the 1% of users. So if all features are launched into production and are guarded by a treatment experiment ID, and we see that the treatment experiment ID is associated with unhealthy metrics, for example, crashes, an SRE can attribute the outage to the feature guarded by the treatment ID, therefore root causing the outage more easily. And then because experiments are gradually introduced into production, there's often the ability to roll back experiments. So once we've root caused outage, we've attributed the cause of the outage. If there's an associated experiment, the SRE can roll back the experiment. So there's this quote from Engineering Reliable Mobile Applications that I think really encapsulates how powerful experiments can be for incident management. And that is, rolling back the feature flag is as simple as ramping the launch back down to 0%, instead of rebuilding an entire binary with the fix to release to the world. So while this quote specifically refers to mobile client applications, it can really be generalized to mitigate any service. For example, if there is one bad feature in your server binary and it is experiment guarded, it can be ramped down without affecting the rest of the binary. And you may ask, why is this very important? Why is it useful that we can ramp down an experiment and not the server binary? Oftentimes when we think about servers, because as SRE, we have more control over the server releases, the server binary releases, and we can control how fast they can be rolled back and whatnot. This can be experiment-based mitigation can seem not as useful, but it's still very beneficial for server binaries because let's use an example. So let's say you have a server binary version 1 and version 2. Version 2 is your current production binary, and version 1 is the rollback version of version 2. But for some reason, version 1 is no longer compatible with a very small percentage of your user base. And then unfortunately, again, you find an outage in binary version 2 and you wish to mitigate the outage. A very standard incident management technique is to roll back the binary version 2 to its rollback version, version 1. However, you could potentially break part of your user base if you roll back to version 1. Note that if the feature that is causing the outage in version 2 is experiment guarded, you can then roll back the experiment to 0%, but still have version 2 in production. So by doing so, you're ramping down to a more stable version and a more recent version. And in this way, instead of ramping back to version 1, where you are ramping back, let's say 10 changes, you are only ramping down 1 change. And thus you introduce fewer changes into production and your mitigation is safer. So experiments can help service owners attain fine-tuned and controlled mitigation. So we've seen how experiments can help with outage and incident management, but how do we promote reliability with experiments? In other words, how can experiments help prevent outages in the first place? So to promote reliable production changes, we should have these policies such as experiments can be ramped up in stages. In other words, we want to roll out to a small population and then a larger population when it is safe to do so. Another way to think about this is we've gathered enough data from the smaller population demonstrating the change is reliable enough to move forward. SREs can enforce further rollouts only if the experiment is healthy to prevent changes that would cause outages in the first place. So you only want to ramp the experiment if it is healthy. And then SREs want to safely transition an experiment to a permanent feature by gradually ramping the experiment to 100% and then think about removing the experiment guard around the feature. So this really allows for more testing, since as you ramp up slowly, you may find that the feature is for some reason not compatible with certain user groups. When you ramp up to a larger population, your user population becomes more diverse. So really the moral of this story is to gather as much data as possible and make the experiment mature before making the experimental feature a permanent production change. For example, let's say I'm trying to ramp a new feature out to mobile phones. At 10%, it's perfectly reliable in terms of crashes. So I could claim that I've gathered my data and that I have proof that this is reliable for the 10% of mobile phones that first received this feature. And I could have reason to say, let's just ramp it up further to 100%. So, but for some reason, the first 10% that received the experimental feature were using mobile devices with Model A. But once I roll out to 50%, I start to see a substantial increase in crashes, because at 50% of the population, the mobile device models are more diverse. And in other words, they are mobile devices that are not just Model A anymore. So ramping experiments in multiple stages allows you to further vet a feature before transitioning it to a permanent feature. So because once a feature is permanent, it's generally harder to roll it back than if you were to just roll back an experiment. So all of these three things I've mentioned can be quite tiring if at every stage you have to manually check if the next stage is an okay traffic percentage to ramp up, or if the experiment is healthy. So we've just introduced a lot of toil into our process in order to enforce reliability. So how do we automate away that toil without giving up our reliability gains? So what we want to do instead is engineer reliability into the experiment lifecycle itself. So we can automate checks at every ramp stage. So you can define codable ramp stages that not only allow developers to get metric signals so that development can move quickly, but also have those stages enforce reliable changes. For example, let's say we define the first ramp up stage of an experiment to be the developer team. Oftentimes you'll see the dev team be a popular choice for the first ramp up stage. And this is because at the first stage, if the team discovers that the feature is buggy, the developer team can jump in and put out a quick fix and then re-release the experiment. And in this case, right, only the internal dev team saw the bug, and there's actually no impact on production. So going back, at the first stage, instead of having an SRE or having a dev verify the experiment is indeed only ramped to the internal team, we can introduce a server that checks if the experiment is ramped up to the correct population. And we can have that server check at every stage defined for the experiment ramp up process. And we can further encode best practices into these policies, into our policies. At each ramp stage, we can mandate and automate that standard reliability metrics are within reasonable thresholds before ramping up the experiment. If such health checks are automated, it reduces the toil on SREs and devs, but still maintains that only reliable changes are introduced into production. The SRE at that point only has to check the experimental feature if there actually is an issue. Then this really ties back to SRE monitoring principles. SREs should ideally be alerted to act when there's a problem. And we ideally should not be spending all of our time searching for the problems ourselves by looking at monitoring graphs. So we've talked about what we can do with experiments today, but what about the future? What might it look like if SREs and experiments evolve together? In other words, how do we get to a place where experiments are a canonical tool in the SRE toolkit? So experiments as change management. So we want to update the existing monitoring and release systems to manage experiment changes as well. This enhances monitoring to improve outage attribution and also allows SREs to develop more policies to automate away human-made decisions about experiment ramp-ups. We want experiments to be part of the canonical production change management system. If experiments are frequently used to shepherd changes into production, they will ultimately affect production. And the change management systems we as SRE use to shepherd changes into production safely should be updated to manage those experiment changes as well. For example, let's say we have experimental feature A out in production, and the current server binary version is version 1. Let's say I update version 1 to version 2 of the server binary in my weekly release. But version 2 is not compatible with experimental feature A, and an outage occurs. This could have been preventable if our change management systems was both aware of the server binary and the experiment feature A's coupling and dependencies. So unless change management systems, in this case, the binary rollout system, are aware of experiments, it can make it difficult to make experiments a standard SRE incident management tool. So what else needs to change in the existing infrastructure before experiments become a canonical mitigation tool for SRE? So one major factor in fast incident mitigation is really how fast your signal is, your monitoring signal is. And many reliability signals need to be real-time or as real-time as they can be. For many metrics used to evaluate experiments, however, statistical analysis is needed. When I say statistical analysis, I refer to calculating the confidence interval for the observed experiment data. Loosely put, the confidence interval is an estimate of the range of values that is likely to include the population average of your experiment, given a certain degree of confidence. For example, we want to estimate the average number of crashes associated without an experimental feature. We'll call this arm A, and compare it to the average number of crashes with the feature. We'll call this arm B. Let's say we've only ramped the experiment up to 1% and we get some data back. Based on the data we observe from 1% of the population, we can calculate the confidence interval to estimate what the range of values the average crash change is. So to present such an estimate potentially requires a complex calculation pipeline, which may not return an actionable signal for SRE in a timely manner. However, some signals SRE care about do not necessarily require confidence interval calculation. In other words, the rigor that traditional experiment analysis requires. So with confidence interval calculations, I like to think the question we answer is, how certain are we that this metric affects the majority of the population? However, if you take a look at like from an SRE perspective, if you see a prolonged and elevated number of crashes in the treatment arm for an experiment, you have a fairly reasonable signal to act and roll back the experiment to a smaller population or roll back the experiment entirely. In other words, SREs can act on slightly less certain signals. So really what we can do is we can trade off some amount of certainty for cheaper and faster monitoring signals for experiments. Another thing we need to do is we need to reduce the experiment learning curve. The learning curve to onboard an experiment and to use experiments effectively can be extremely high. So how do SREs persuade teams to use experiments so that we as SRE can then enforce reliability more easily by using experiments? So immediately SREs can try to automate away the difficult experiment onboarding parts to reduce the onboarding learning curve. For example, we can provide command line interfaces, onboarding templates. And these will not, providing command line interfaces and onboarding templates will not only reduce the burden of onboarding, but also by introducing these tools, you're standardizing experiment onboarding. And by doing so, you can reduce many experiment configuration mistakes. So ensuring minimal configuration mistakes can easily reduce the debugging time and thus the mean time to resolution of a potential experiment outage. And further down the line, as SRE, how do SREs adopt experiments for incident management more easily? In other words, what needs to change in order for SREs to use experiments for incident management? As mentioned in the beginning, primarily developers have been the experiment's main user, and feature popularity as the main measure of success for one possibility then is that experiment infrastructure teams can expand their customer base to view SREs as a customer and reliability as a measure of success and evolve experiments with SRE input. That is actually the end of my talk. Thank you for listening to my presentation about experiments. I hope you are able to take some of today's concepts and apply it to your own work. Perhaps you may integrate experiments into your team's incident management playbook and service management. Thanks again.